All right, so here we go. We're going to talk about section 3 now, which is about rates of change. So the rate of change is just describing how one value is changing in relation to another value. So the average rate of change, that's going to just be the change of the function values, the outputs, divided by the change in the input values. So you've actually seen this concept before because this is basically the same as slope, where you have m equals y2 minus y1 divided by x2 minus x1. So I'm sure you've probably seen that before in previous algebra classes where you're calculating the slope. Another term for the slope is the rate of change. Slope and rate of change mean the same thing. So anyway, this here, instead of writing it as y, they're saying f of the second x. This is basically equivalent to the second y value. This is equivalent to the first y value. So f of x2 is equivalent to y2. It's the second y value. F of x1 is the first y value. And so like if you've got some points, you've got you've got x1, y1, or you could write that as x1 f of x1, because the y value is just what the function spits out using that x value. So it's just a different way to write it. It probably makes it more complicated than it probably needs to be. You might have seen this notation before, delta y over delta x, and that just means delta, they use that to mean the change. So this is called the change in y and the change in x. And so again, if you calculated the slope before, that's really all this is. They're doing a lot of fancy terminology and notation and probably making it seem more complicated than it really is. But if you found a slope before, that's really all this is. Subtract the two y values, subtract the two x values, make a fraction of change in y over change in x. So like here, using the data in table 1, find the average rate of change between 2005 and 2010. So this would be x1, the first x value. This would be this would be x2. Sorry. This would be x2, the second x value. So here's and just to make things more obnoxious, they're actually using y for these instead of x, which is kind of weird. But anyway, these are the two values that we have. So I guess strictly speaking, this is y1 and y2 is what these are. And then what we need are the output values that go with them. So C of y1, that's this value right here, which is 2.31. C of y2 is 2.84. So like you could write these as coordinates. You could call this 2005, 2005, comma 2.31. And then you've got 2010, comma 2.84. And then again, this kind of thing I would expect you've probably done in classes in days gone by. So like you call this x1, you call this y1, you call this x2, you call this y2, and you're just finding the slope. You'd say m equals y2 minus y1 over x2 minus x1. And so to find the delta, what is it? The delta of C of Y, because they got kind of a wacky naming system going on here. Delta C of Y, that's going to be 2.84 minus 2.31. And then we'll have delta Y, which is 2010 minus 2005. The bottom is just going to be 5 because that's 2010 minus 2005. Let's find out what 2.84 minus 2.31 is. That is 0.53 is what that is. And then we can do 0.53 and divide it by 5. And if you do that, you will get 0.106. And so basically the rate of change is 0.106 each year. That would be the answer. So some of the notation and terminology may seem a little complicated, but like I said, if you've calculated a slope from algebra classes in years past, it's not really meaningfully different than that procedure. Okay. Let's see what else we have going on here. What is this? Find the average rate of change f of x on f of x, where you've got x minus 2 root x on the interval from 1 to 9. So here's basically what that means. They want you to plug in the first value, which is 1, see what number that spits out. So let's do that first, shall we? F of 1 is going to equal 1 minus 2 times the square root of 1. The square root of 1 is 1, so that's just 2 times 1. 2 times 1 is 2. 1 minus 2 is negative 1. So that means f of 1 is negative 1. If you were to write that as a point, the x value, the input, was a 1. The y value, the output, was a negative 1. So this would be in kind of standard, more standard notation. This would be x number 1. This would be y number 1. So the number that went into the formula was 1. The number that came out, they went with it, is negative 1. So then we're going to do that all over again. This time we're going to use 9 because that's the number they want us to end with for this interval. So f of 9, that's going to be 1 minus 2 times the square root of 9. The square root of 9 happens to be the number 3. 2 times 3 is 6. 1 minus 6 is negative 5.
9 minus 2, why 1?
Oh my gosh, you're right, you're right. You're right, oh my gosh. It's been a long day, I'm sorry. What is that? 9 minus 6, which is okay, so that's 3. There you go. That's 3. How about that? Okay. I need to slow down is what I need to do. Okay. So what is this? This is 9, that's a 3. Okay, 9 comma 3. There you go. So then what is this? This would be x number 2. This would be y number 2. And let's see here. So we're going to do y2 minus y1 over x2 minus x1. That's going to be 3 minus negative 1. That is going to be 9 minus 1. The top is going to give you 4. The bottom is going to give you 8, which is going to be 1/2. And that is the rate of change, which is also sometimes called the slope M. So the slope is 1/2. Okay. Let's see here. So let's see what else we've got here. All right, find the average rate of change on the interval 5 to A. So this one's going to be a little bit different here. Let's see, this is 5 where we're going to start. So we're going to start by putting in the value 5 into this function here. So what is that? That'll be 5 squared plus 2 times 5 minus 8. That is 25 plus 2 times 5 minus 8. That's going to be 25 plus 10 minus 8, which is 35 minus 8, also known as 27. 27. So that's f of 5. Next, we've got f of a. So this will be fun. So f of a is just going to be a squared plus 2a minus 8. And that's all you can really do with it, quite honestly. So what this would mean is that you've got 5 comma 27, which would be x1, y1. And then you would have a comma a squared plus 2a minus 8. So instead of numbers, we're going to have a formula, which may seem a little wacky, but that's what it is. So what do we always do? Well, we say, okay, we're going to do y2 minus y1 over x2 minus x1. So y2 is this big old thing right here, which is a squared plus 2a minus 8. All of that is y2. And then we are going to subtract y1, which will be 27. Underneath all that, you're going to have x2, which is a, minus x1, which is 5. So it's a minus 5. We can clean this up a little bit. -8 minus 27, that'll give us what? Negative 35. So that'll be a squared plus 2a minus 35 all over a minus 5. And that's the slope. And then we're not quite finished yet. This will be as good a time as any to remind ourselves how factoring works. Yes. So if you've got a squared plus 2a minus 35, so to get a squared, you'd have like an a and an a. Yes. To get 35, that could come from 5 times 7. And to make that positive 2, you'd basically need -5 plus 7. -5 plus 7 is positive 2. -5 times 7 is -35. So we will in fact end up with a minus 5 times a plus 7. And then what you will notice is that you've got a minus 5 down here, which means that can cancel out with that. So it turns out the rate of change is just a plus 7. With the caution that a cannot equal 5, because if you put in the value of 5, this would give you 5 minus 5, which is 0. So a cannot equal 5. But provided a doesn't equal 5, that would be the rate of change for this. So a plus 7, where a is not equal to 5. Okay. Let's see what else we have here. So next we'll talk about increasing and decreasing on intervals of the function. And so here they've got these different intervals. So let's kind of break this down a little bit here. So you've got this point right here. The term for that, in case you're interested, that's called an inflection point. Actually, no, I'm sorry, that's something else. That's just it's the maximum is what it is. An inflection point is actually something different. This is it's the local maximum. So in that general neighborhood, it's the highest point that there is. It's the maximum point in this general region. You'll see here that the graph does keep going up. So there are points above it in other places, but in this general neighborhood, this is the big man on campus, if you will. And then we got this down here. This would be like the local minimum is the name for that. And so that's where it's changing from going up to going down. That's where it's changing direction. So you read the graph left to right. So you read left to right. And so basically what's happening is that starting here, the graph is going up or increasing. Yes, so there's where it's increasing. Starting here, the graph is also going up. So it is increasing over there. In the middle, going from there down to here, you will notice it is decreasing because it is going down. So just like when we were writing intervals for the domain and the range, you can write intervals for increasing or decreasing. So we could say it is increasing. So from negative infinity to -2. So from negative infinity to -2, that is one place where it is increasing. And then from +2 to infinity, that is another place where it is increasing. And they do say that down here, like it's just the same thing that's down there. Decreasing, by the way, that's going to be this single interval from -2 to 2. And here you are giving x values for where it goes, either up or down. So that's what the increasing and decreasing, that's what you would do, is you would give an x value, you give a range or an interval of x value, you give an interval of x values to describe which parts of the graph are going up, and then which parts of the graph are going down. So like here, this is kind of the same picture. And then here, they're also talking about, I kind of mentioned this on the last slide a little bit, but so like the local maximum is 16 and it occurs at -2. So this point right here, that is the local maximum. As you can see, the graph keeps going up. So there are points higher than that, but local to this area, this is the high point of this bump. And so the max is the Y value and it happens at -2. Similarly, the minimum is down here on the other side. The minimum is at -16 and it happens at +2. So what I will say about this is the max or min is the Y value. So that if it asks for a maximum, you're giving them a Y value. If they want to know where it happens, the X value is where it happens. Okay, so what else do we have here? So this is kind of a more formalized definition. So it's an increasing function on an open interval. If for every A to B interval, B is bigger than A, it's decreasing if if the f of B is less than f of A. This is kind of a more formal definition. I think the more straightforward way to do this is if you have a picture in front of you, it's, in my opinion, not that tough to just look at a picture and be like, okay, here's where it's going up, here's where it's going down, here's where the high point is, here's where the low point is. And so a local max is where f of B is greater than every value on the interval. So it's local because it's not necessarily the highest value ever. It's just that in a particular area, it's the high point. And then local minimum is basically where it's less than all the values in that interval. So they say graph the function x cubed minus 6x squared minus 15x plus 20 to estimate the local extrema of the function. Use these to determine the intervals where it's increasing or decreasing. Extrema, by the way, or extrema, this is basically a way to say max or min. So instead of saying max or min all the time, you've got kind of one catch-all term that means the extreme points, the maxes or the mins. Extreme. Okay, anyway. Let's see, where were we? Let's break out the graphing calculator, shall we? So here we go. So we're gonna turn on here. We're gonna go to y equals. Let's clear out what we had there. We had x to the third. So again, this button right here next to alpha is where the x is. This button, this little kind of pointy caret thing, is how you can get your powers. And we'll type in 3 to do x to the third. And then to show that we're done with the power, I will arrow over to get back down to normal land. What's the next thing? It's minus 6x squared. So we'll just do minus 6. X is right there. And then the squared key is that one. Okay. Then what do we have? We've got minus 15x plus 20. So here you go. I got minus 15x plus 20. There you go. You got all typed in. You hit enter. And then you can go to graph and you can look at the graph. And there goes whoop, whoop. And you might notice some of the top and bottom is cut off. So here's what we will do. If you look at the top there, there's a button that says window. So we will push the window button to change our window. Now, if you want to make the picture wider, as in move farther left or right, you want to change the min or max for the X values. Now, the problem is I can't see the top and I can't see the bottom. So I want to move the picture up and down. So if we're going to go up and down, that means we want to change the Y's. So let's change Y min. Let's maybe try negative 20. And then let's change Y max to, I don't know, let's change it to positive 20. And then we'll go back and hit the graph button and see if that, okay, that's a little bit better, but we're still not good enough here. So maybe we'll try, let's see here. Window is the button I want. Here we go. That's all. No. Let's see. So window. Let's try 50 this time. Let's try negative 50 and then positive 50. We'll do that this time instead. Just keep widening our range until we end up catching the whole graph. All right. It's high enough. We can see the top bump, but we still can't see the bottom of this bump right here. So let's go back to window and let's push the right button here. Here we go. So we still want the Y min to go lower. So I don't know, let's go all the way down to like negative 80. Let's try that. It was high enough, so we just need to make it lower. So let's make the Y min negative 80. And we can graph this. Hey, would you look at that? All right, that's a beautiful picture right there. All right, so we want to find the min and the max. So here's how you can do that. There is a button that says trace on it, and directly above it, it says calc. And so what you need to do is you need to push the second key and then push the trace button to get to the calc menu. And you will notice there are options down here. One is for maximum and one is for minimum. So I'm going to arrow down and I'm going to pick this one right here for minimum, and I'm going to press enter. Now it will say, give me a left bound. So the minimum is like right there. So I need to move the cursor left of where that point is. So we're going to push this button a whole bunch of times. You can hold it down and we'll move over here. And then we're clearly to the left of where the low point is. So I'm going to push enter. And then it's going to say, give me a right bound. So then I'm going to go push the arrow key and go over to the right, move the cursor. So I'm very definitely to the right of where that is, and push enter. And then it's going to say guess. So then I'll kind of move back here and I'll kind of give it get the cursor as kind of close as I can. Press enter. Oh gosh, what happened? All right, let's try this again. So we're going to go. So we'll go to the left side. Could be because I'm doing this as the mirror image. I'm doing it. So we're going to go to the left, we're going to go to the right, and then we're going to go down to the bottom. Okay, so there you have it. You put a point on the left, you put a point on the right, and you can see there it's 5.000001. So it's basically the number 5. So the 0.5, negative 80, that is the low point of that graph. So go ahead and share this here again. And let me draw kind of a rough sketch of what this looks like here. So it goes up like this, and then it kind of curves down, and it goes down and around, and then it goes up like this. And so when you find the minimum, that is going to be the 0.5, negative 80. And then we're going to do something very similar to what I just did to find the maximum. So again, we're going to go to second and the calc menu. This time we're going to pick the one that says maximum. All right, so it asks for a left bound. So the maximum is up here somewhere. And let's see, I want to move the cursor so that it is to the left. I'll push the arrow keys. I'm actually going to look at it head on. Okay, let's try this. So that is the left of where that is on that picture. And we'll push enter. And then we need to move it over this way so that it's now to the right of where the high point is. You push enter. And then we back up. It asks us to give it a guess. So we do like somewhere in the middle there. Press enter. It'll grind that out. And what does that say? That's like negative 0.999. So basically negative 1. And what is that? 28. Negative 128 is what that is. If we round that off. So I will share my screen here. So this point is happening up here at negative 128. So graph the function to find the local extrema. Use these to determine where it's increasing and decreasing. So the local max is negative 128. The local min is 5, negative 80. So let's see, where is it going up? Well, from here to here, it is going up. And from there to there, it is going up. So it is increasing. I'll just put INCR for short. So from negative infinity to negative 1 is one of the places where it is increasing. And then from 5 to infinity is the other place where it is increasing. So that is where this function is increasing. And then in the middle, do that in green here. This chunk right here is where it is going down. So it is decreasing. And it's going from negative 1 to 5. That is where it is decreasing. You'll notice when I give these intervals, you're just always going to use parentheses. You don't necessarily have to worry about whether it's included or excluded. You just always use parentheses by default and keep it simple. Okay, so that is how you can find local extrema and how you can find things that are increasing and decreasing. And the big thing is knowing how to use the graphing calculator to help you find the high and low points after you get the picture. So hopefully that kind of walkthrough of how to use the graphing calculator was helpful. Let's see, what do we still have left? Okay, this last bit, we can knock this out in 10 minutes. That's fine. All right, so absolute maxima and minima. So basically, it's bigger than every single point. So it's not just it's the high point, but there are points higher somewhere else. If you are the absolute maximum, it is the highest point, period. There are no points higher at all. Same for an absolute minimum. It is the absolute lowest it ever goes. It doesn't go any lower than that. So here they have a picture for us. And they say for the function in this picture, so there's a picture right in front of us, and they want us to find all the absolute maxima and minima. So here we go. Here is a high point, and here's another high point that's just as high as the other one. So this one is -2, 16. This one is +2, 6. That's +2, 16. Both of those are going to be absolute maxima. There are two of them. There can be more than one. That's okay. That is a thing that can happen. So there are two absolute maxima on this graph. Maxima is the plural of maximum, if you did not know that. All right, now, when it comes to the minima, the thing to notice, this is about halfway between here. So this is going to be the point 3, -10 is where that is. That, for this particular graph, for this picture, the absolute minimum is 3, -10, because that is the lowest point, the lowest it ever goes on this graph. There is only one absolute minimum, which is at 3, -10. I will point out that maybe we'll do this in, I don't know, yellow maybe? There's this point, which is 0, 0. That is a local minimum. That right there is a local minimum in that general sort of neighborhood that is the low point, but it's not the absolutely positively lowest point ever on this particular graph. So that would be a local minimum, but it is not the absolute minimum. So hopefully you get a sense of how they are different from each other. And one thing to bear in mind, yes, it is possible to have an absolute min or max on the very end, on the very edge of a fixed interval. But that is the distinction between how an absolute min or max is different than a local min or max. And then the other thing I'll point out too, the absolute max is itself a local max. Like, you know, if you look at just this general neighborhood for this bump, that is the local max there as well, but it's also an absolute max of that graph as well. All right, so anyway, that is the end of section 1.3. Okay, so I did go ahead and take the attendance while we were having our break. So I'll go ahead and start.